going to walk you through how to progress through Tech Assignment B. So click on Tech Assignments, Technology Assignments, and then scroll down to Tech Assignment B. You'll see the due date, midnight of the day before Unit Test 2, 20 points possible. There's a share link that you'll create through Desmos that you'll upload to Blackboard. Criteria C rubric, so you can scroll up and see all that information. Problem solving and perseverance, accuracy of submission. So you can see that there's the weight associated with doing everything correctly. That's the accuracy, but then there's also a component that's just how you go about completing the task. All right, and just be mindful of the fact that every tech assignment has a corresponding discussion. So it's not going to state that here, but there will be an announcement for a discussion that you'll need to participate with, and you'll get credit for that. All right, so you can read through the blurb here. All right, when you name your Desmos file, name it with last name, first name, Tech B. Watch the discussion, the instructional videos in the overview playlist. Work through the attached assignment, and again, the discussion piece here. Any constructive criticism, you'll graciously accept any of that, and then make sure you get it in by the deadline. All right, so you click on the assignment and make sure you open Desmos. All right, open a new blank Desmos to get started on this. All right, so I'll take you through that whole process now. Those assignments as procedural as possible, so you gain insight in how the technology works, but also you get a good idea of what the statistics manifests itself as using that technology. All right, so in some ways it's can be a little bit more user friendly than others, but there's a learning curve. But once you get a handle on that learning curve, it does make life a lot easier. All right, all of the things that we're going to do here can be done using a TI-84, but the whole idea is that Desmos is free. And so anything that we can do with Desmos is going to be a better option, because TI calculators cost $150 if you want a halfway decent one, right? So free versus $150. I think that answer is obvious, right? So you see the example here. Now you also see the answer and the progression. So I'll take you through all that, but your assignment starts on the third page. All right, so you don't have to submit the first 2 pages, but I'd like you to try it at least on your own before you get started with the actual assignment. All right, so just try to follow along. Pause the video as needed, obviously. So I'm going to click on the add item button, so the plus sign. Right, that's generally my go-to if I'm unsure as to what I'm going to type into a field, because it gives me some options. It kind of gets me thinking in the right direction. So we have f of x. I want to type in an expression, or I want to make a note. I want to put in a table. So we're going to put in a table here. I can create a folder. That's a little bit more advanced. I can show you how that works in a little bit. And I can also put in an image. The benefit of an image is if there's something that I want to include in my Desmos that I just can't figure out how to do on Desmos, but the assignment calls for me to submit something on Desmos, what I can do is I can do it by hand, take a picture of it, and then upload the image into Desmos. Right? So I'm still satisfying the requirements of the assignment. All right. So I'm going to, for now, click on table, and you see here it defaults with an x1, y1. And the values for time, those are my x1 values. Temperature are my y1 values. So 0, 2, 4, 6, 8, and so on are going to go in for x1. So I'm going to type those in. Now you see here, after I put in the first couple of values, Desmos recognizes that there's a pattern, and it anticipates that pattern by plugging in the next entry of that sequence. So we have 0, 2. It says, okay, we're going by 2. So next one that you want is 4. If it's anything other than that, you overwrite it. It gives you that option. But all you have to do now is hit enter. 6, 8, 10, 12, 14. And then now you see there's no pattern to the data on paper for the temperatures. and Desmos doesn't recognize a pattern, so it's not going to autofill anything. All right, so you got to be a little bit more careful here. Oops. All right, so I have my data in. I can hit enter an additional time. It creates an extra field, but that doesn't matter. All right. If you want, you can delete it if it makes you feel better, but it's not going to make a difference in the computational aspect. All right, now you see nothing appeared on the screen here in terms of the graph. So you can handle that a couple of different ways, because you can see on paper here, there clearly is an image. So, but you could also see the dimensions of the graph are from 0 to 15, so a little bit further over, and then from 0 to 100. So a couple of ways to handle that would be to pinch zoom if you're using a touchscreen, or if you're using a mouse, you can roll the mouse. But the best way to do it, I think, would be by clicking graph settings, which is that little wrench, and just manually manipulating the domain and range. Right, so the low bound for x, I want that to be 0. The high bound for x, basically what I tend to do is choose convenient values that are around the minimum and maximum for each variable. So time goes from 0 to 14. So I'll go from 0 to 15. Those are nice convenient values. All right. Lowest value for temperature is 44.4. The highest value is 94. So you might say I'll go from 40 to 100. All right. But if you want to see the x-axis, you definitely want to get a y value of 0 in there. All right. It's not always necessary, but if you can, it's worth it. All right, so, and then you can zoom from there, and you can see it's a little bit of a better view. All right. Now, from there, what we want to do is create regression models. All right, so I want to be able to fit a line, a quadratic, and an exponential function to these data points. Now you can see here it's not quite linear. All right, it's got a linear aspect to it, but it does also has a slight little curve to it. This one extra point here, 849, seems to throw things out of whack. But if we were to ignore that one, pretend it's not there, it almost looks like an exponential curve. You can make a case for quadratic depending on the context. So what I'm going to do is click in a new field here and just start typing. I want to get y1 regressed to a plus bx1. All right, so y1, so just type in y followed by the number 1. It automatically recognizes that as a subscript. Then you can use the tilde symbol, so shift and whatever that key is right next to the 1. Looks like a kind of a backwards apostrophe. If you hit shift that, it's the tilde. Then a plus bx. All right, I'm sorry, a plus bx1. It's very similar to y equals mx plus bx, just we use this form for consistency with other types of models. Now you can see here that it presents you with an r squared value. All right, that r squared value is known as the coefficient of determination. The closer that value is to 1, the stronger the relationship is. All right, so I'm going to go into my next field and type in the quadratic model, y1 tilde ax. Now you could use the caret symbol, so shift 6, it creates a caret, or you can go to the keyboard and you can see all these different options here. A squared brings up a power of 2. All right, but I'm kind of a little bit more accustomed to the keyboard approach. All right, so that's the power of 2, but we do need an x1 first. So let me do the x1, then shift 6, power of 2, right arrow to get out of the power of 2, plus bx1 plus c. And again, you see that a bunch of other information is presented along with the curve on the graph. All right, this one seems to be a better fit. All right, we have an r squared, capital R squared this time. All right, still coefficient of determination, 0.9701. All right, so now we go for exponential, y1 tilde a times, so I'm doing shift 8 for times, but you could also use the multiplication symbol, b raised to this, so shift 6, x1, and it gives you an r squared value of 0.9544, which is not as good as the quadratic one, the x squared one. All right, so the quadratic model is the best fit, so I would turn off the ones that I don't want. So I'm not going to delete them. I'm not going to hit the X. I'm just going to turn off the icon next to it so that the only one that appears, because these other computations here are my evidence that I investigated to see which one is the best fit model, showing that this is the winner. All I need to do is turn off the ones that are not the winners. All right. So what I would do now is just work with this function exclusively. Now, context should be an overriding factor behind any situation. So you could look at this and say, well, the math says quadratic, but context tells me exponential because, we're talking about a bun taken out of the oven. Is it going to reduce itself in temperature till it gets to, what is that, like around 45 degrees? And then start increasing in temperature until it gets to 200 degrees just on its own? Probably not. All right. What's more likely, that or coming out of the oven, reducing in temperature, and then leveling off in some capacity? Probably leveling off. The only problem with this is the model that we have for the exponential has it leveling off around 0 degrees. All right, so I suppose it depends on where it's being placed. It's a bun taken out of the oven. Is it being placed in the freezer or is it being placed on the counter? If it's being placed on the counter in an ordinary kitchen, roughly 70 degrees, then why would it get down to 0 degrees, right? So the math is telling us quadratic, context is telling us some kind of exponential function, but maybe not this exponential function. But at this point, this is all we have, so this is what we kind of live with. All right. So that takes care of this stuff here. Now, using the best fit model, which is, again, the one close with the best r squared value, which is the one that's closest to 1, evaluate the function at x equals 10. All right. So what I'm going to do is I'm going to rewrite this function. But instead of rewriting it as y1 tilde, because y1 is defined, it's regressed in 3 different ways. If I say y1 at x equals 10, Desmos is going to get confused. It's going to be like, which y1 do you want? So what we do is we rewrite it. We type in f of x equals, what I just did is I just did a quick control C or command C, depending on your device. Basically copy this and paste it and just get rid of the ones now. The little subscripts, get rid of those. You could just retype it too. It's really not that big of a deal. But the idea is that you're using these A, B, and C values now. All right. So what you can do is delete these and see now that you have the model accounted for using this new function. All right, but if you don't want to delete them, all right, so if you want to keep those other functions, then you would have to retype it using these coefficients. All right, so it's not that crazy of a situation, but it's just a question of what you want to type. All right. The bottom line is we want to have a nice convenient way of computing what f of 10 is. The easy way of doing that would be to type in f parentheses 10, oops, that's a 1, 10, and hit enter once you have your function typed in here. All right. So, like I said, if you wanted to leave those other 2 functions in there, which is usually a good idea, just to have evidence that you investigated the appropriate regression model, then you would type in the A value, the B value, the C value as approximately 0.217, the B value negative 6.594, and the C value 94.875. So you just type that in straight away. All right. Now you can also figure out the X value that corresponds to a certain Y value. All right, so let's say, for example, in this, in number 5, it says, use the best fit model to find the time when the temperature is 68 degrees. So what I would do is I would just type in an equation y equals 68, because the y value corresponds with temperature. So anywhere along this black line here, there's a temperature of 68. You see the y value no matter where I am? The y value is 68. All you'd have to do here, you can see if you click on the black line, you see there's some gray dots that appear at the intersection between the green curve and the black line, right? Those locations are the instances in which the x value corresponds to a y value of 68. So we now know that at 4.851 minutes and about 4.851 and 25.5 minutes, the temperature will be 68 degrees. All right. Now, if you want extreme values, that's pretty easy too, because all you have to do is click on the green curve. Extreme value is the lowest and highest. Now, a parabola doesn't have a highest value because it's infinite. All right. I mean, I suppose you could say its highest value is infinity, but that's not really saying, the most or the least as being infinite. That it implies a cap. There is no cap if something is infinite. All right. But if you want the lowest value here, there is a defined lowest value. You click on the green curve, you'll see that gray point appear at the minimum. Click on that gray point, and you'll see that the minimum point is at the coordinate 15.175 and 44.842. All right. So that tells us, the x value is time, the y value is temperature. So it's telling us it's going to get to a temperature of 44.842 degrees Fahrenheit after 15.175 minutes, right? Or at the 15.175 minute mark. All right. So your assignment is basically just do the same thing, just with a new data set. It's different context, right? Now, this one is talking about just a quadratic regression model. So I'm kind of trimming it down and going piece by piece. And you'll see number 2 is just talking about the exponential regression model. But you're following really the same progression. All right, so you're completing all of this in Desmos. Suggestion, make a separate Desmos for each question. All right, because what happens is when you make a table here, like for example, we just made a table for the example problem. So let's say I want to do the assignment question number 1. If I create a new table here, I'll put the plus sign, and I'll put a table in there. Since I've already used x1, y1, it's going to come up with something else, usually x2, y2. I don't know why it's going to x3, y3, but bottom line is it's not going to let me use x1, y1 again. All right, so what I would do is create a new graph. All right, so new blank graph. This is an example, so you'd save this. So click on Untitled, go to save. This is Can Tech B example. Once you save it, if you click on this little share graph icon, you'll see that a share link appears. Copy that. That goes into Blackboard or a Word document that gets uploaded to Blackboard. Either way, as long as your final submission gets sent to Blackboard in some capacity, you'll be fine. But then once you do that, new graph, then when you click on the plus sign and go to table, you'll see you're back to x1, y1, and you can follow the steps. But again, for assignment number 1, you're only doing quadratic regression model. For assignment 2, you're only doing exponential regression model. All right. So hopefully you found that to be helpful. If you have any questions, message me.